Hello there, this is Jeffrey. Going to start this video, this lesson, just by explaining the different types of data you can use in Java. This is all stuff that's very useful to know. Not all of it will be on the AP test. In fact, only a few of these, I'll highlight them here. Integer, double, Boolean, are going to be on the AP test out of the instance, or rather I should say, data types that you see here. But I'm just going to go through all of them because they're all very useful to know. These first four here are what are called the integral types. The integral types represent any non-fractional number up to a certain maximum and down to a certain minimum value. For example, byte will only store values from negative 128 to positive 127. These all have their other limitations in terms of how high they can go. Long is the one that can get as close to infinity as any primitive type is going to get, which is very high. It's much bigger than you'll need for any program. The standard one to use is int. Whenever you see numbers being passed around in integral form, they're almost always going to be an int. That's why it's on the AP test. But it's good to be aware that there are actually 4 different integral types. The only reason you would ever choose something above int is if you had memory limitations on your computer. For the case of byte and short, they take up less computer memory. Or in the case of long, if you knew you're going to need a big number, you could go with long as a way of circumventing the capacity of int, which is admittedly pretty high. You will almost never hit that, but it's just good to be aware that there are other options besides integer, int in this case, that you can look into if you need to store those big numbers. So all they'll do, they all work by the same operators: plus, minus, asterisk for multiplication, and slash for division. The only thing to note about any sort of mathematics that goes on here that's kind of odd is that if you're using integers, suppose you have here I'll turn this one into an, well, actually I can keep it as a long, it doesn't matter. If I do d divided by c right here, the returned value is not going to be 3 halves or 1.5. The returned value is actually going to be 1. And the reason is when you do integer division, it truncates any decimal there is after the division. Because since neither of these values has a decimal in it, the computer won't allow a decimal value to be returned. So the way Java handles this is basically by truncating that decimal and saying, okay, 3 divided by 2 is 1. And so that's the only thing you need to know with these data types. For float and double, there are a few really important things that are going on here. First of all, notice that at the end of double, at the end of float, there's an F right here. If you don't have that F, it's going to throw an error and say that's not a valid float. And the reason is that doubles and floats have different precision in computer memory. The float is precise up to a smaller number of significant figures than the double is, although you don't have a theoretical limit necessarily on the value most of the time. It's just that it isn't very accurate after a certain point. So you put an F here because if you didn't, you would be essentially trying to assign a double right here. This 2.7 would be considered a double to a float. And Java does not allow a loss of precision unless you do an explicit cast, which would be saying cast an explicit cast to float of that value. But as essentially an abbreviation of this, you can just put an F at the end. That's the only reason that's there. Note, for the long, you can write an L at the end of it. Not necessary. You can take the L out. It still works for longs. It's only for floats and doubles that you see this. For the only other big thing to know about floats and doubles is that since they have a certain number of significant figures and only a limited number of them, they're actually pretty inaccurate. If you do repeated calculations of, say, 3.1 plus 1.0 minus 1.0 plus 1.0 minus 1.0, and you do this a trillion times, at the end your value is not going to be 3.1. The way it works inside the computer basically says, yeah, it's going to be something else, and you don't really know what that is. You've got to be careful using floats and doubles, because repeated operations on them, even basic operations, will lead to error. So it's good to be aware that if you need something to be absolutely precise, double and float might not be exactly what you're looking for. For the most part, it's fine. For the most part, you don't have any problems with that. But just be aware that that does exist. Booleans are very easy. They can only be true or false. So in this case, I'm assigning it to a value of true. That's it. It has a value of true. You can write false there, and it's got a value of false. Booleans are very simple. And there's only one type of them, which is very nice. The last primitive type included in Java is the character. And the character really is just a glorified integer, because if you have ever seen the ASCII character chart, all it does is equate integer values to a character representation. So in this case, as I'm showing you down here, you can say that a character is equal to some type of integral value, or that an integer is equal to a character. And in this case, on the ASCII chart, 65 encodes a capital A. So the program actually thinks that I and J are the same, and the only reason that they print out differently is based off of the type they are declared as, and not based off of what the value right here. If I were to say print out I could cast this I to int and print that out, and it would print out the integer representation of it, because really characters and integers are very similar. The only advantage of a character is you don't have to memorize the entire ASCII chart just to print out or assign something to a character. So that's all characters is. Note here the single quotes. If I had put double quotes here, that would be a string, something I'll get into in a later tutorial, and it's not the same thing. Just make sure you're using single quotes there. And that's basically it for data types. The only other thing I would like to take some time to point out now, something I've touched on before, is the cast. I showed you with float, if I took this f off here, I would have to put a cast of float here. Whenever you put something in parentheses like that, a data type in parentheses, you're saying take whatever comes after it and make it of this type. And as long as there are similar types, you can do this. So in this case, all numeric types can be cast to each other. So if I have, for example, if I turn this into an int, this is going to throw me an error, but I can say cast to int. Now it's fine. Notice that any cast to int will truncate a decimal. So in this case, f is now equal to 3, and writing the 3.1415 was of no use because it's just a value of 3 now. And of course, since characters and integers are basically the same thing, you can cast between character and integer as well. You could probably cast between character and double, although that's ridiculously complicated and I don't see a valid reason for that. But if you really want to, like if you want to just prank someone and write some really obfuscated code, go ahead and try that. It would probably work. Booleans cannot be cast to any of the other types here, because in some languages the Boolean value of false is equated to 0 and true is equated to 1. That's not the case in Java. So there is no way to cast a Boolean to another type. You keep Boolean at Boolean. That's about it. So that's it for primitive data type. Thank you guys for watching, and that is it.